All right, let's take a look at a couple more examples. Now, we're going to go through these examples without using, I'm going to kind of skip a couple parts, but we'll do those in class. So if you're struggling with some of that stuff in class or outside of class, please come talk to me and we'll go through it. So number one here says, create a linear system in order to model each situation, then solve the problem using graphing. Now, the first one here is the stage in a theater is rectangular. Its perimeter is 158 feet, and the width of the stage is 31 feet less than the length. And so we need to figure out what is the length of stage and y, x and y we're going to use. What is the width of the stage? So we need to figure out those two things. Those are going to be our variables. Now, if you want to kind of think about this as just a rectangle, remember we have a rectangle, we have a length, we have a width, okay, and we're kind of told a couple pieces of information about this here. So the stage in the theater is rectangular, there we go. The perimeter is 158 feet. Now to find the perimeter to this, we're going to take 2 x's, which is the length, plus 2 y's, and that is going to equal to 158 feet, or 158. We won't worry about this here represents the perimeter. Okay, so we can do that to find the perimeter. We're also told that the width of the stage is 31 feet less than the length. So our width has to be equal to our length minus, I guess I'm using L, x minus 31. So this here is our difference. Okay, so we come up with our two equations. Now, just as a point of reference, our domain, in this case here, x has to be greater than or equal to 0 because you can't have a 0 width or 0 length. Technically, it could just be greater than, it doesn't have the equal sign. And the range y is also greater than or equal to 0. Technically, I guess it could be 0, be like nothing, but that just wouldn't really work. So it's got to be greater than 0. There's our domain and range. Now we graph this out. Now these equations here are somewhat complicated to graph out. Not impossible on graph here, but we can get a more accurate answer if we were to plug these into some graphing software. Now in class, I'm going to show you how to do graphing software, and maybe at some point I will incorporate that into this video as well. But for right now, let's just say that we have graphed these out on graphing software, and we've come up with our solution, and that solution is 5524. Okay, this is our answer or solution. Okay, without graphing out here, we've graphed it on DESMOS. DESMOS is a program that we're going to use, and this is the solution that we came up with. Okay, what does this tell us? Well, x is the length of the stage. So the length of the stage is 55 feet. And the width is y, so the width is 24 feet. So the stage is 55 feet long by 24 feet wide. Now, if you're curious about these here, okay, 55 and 24 have a difference of 31, okay, that's what we had here. And if we were to do 2 x's plus 2 y's, we would get a perimeter of 158 feet. Okay. Again, DESMOS will help us get a little bit more of an accurate answer, and it'll be a little bit of a quicker answer as well. The big thing here is going to be making sure that we can come up with our equations. Now B, a display rack of batteries had packages of 8 and 4. The total number of batteries was 320, and there are 1.5 times as many packages of 8 batteries as packages of 4 batteries. Okay, so again, we have two things that are kind of our unknowns that we want to try to find, and those unknowns that we have, okay, are the number of packages that we have. So x is going to be the number of 8 packs, 8 battery packs, and y will be the number of 4 battery, put that in here, packs. Okay, so we got number of packs, and we don't know how many packages of each there are, but we know that we have a total of 320 batteries. To figure out the total number of batteries, what we're going to have to do is we're going to have to take the number of packs that we have that have 8 and multiply it by 8, the number of packs that we have by 4 and multiply by 4, and that will come up with 320 batteries. There's our first equation. The second one, okay, is a comparison statement. Okay, it says that we have to have 1.5 times as many packs of 8 batteries. So that means that we're going to have to take our Y value and multiply it by 1.5 in order to get our X value. Okay, so we have to multiply the Y value by 1.5 to get our X value. Okay, that's what it's telling us, because there's 1.5 times as many of these packages. All right, now we have our equations. We take and plug them into DESMOS. And when we do that, we're going to get a solution of 30, 20. Okay. Now, if you haven't been using DESMOS, that's okay. You can now use these numbers, right? So if we take 20 times 1.5, it gives us 30. If we do 8 times 30 plus 4 times 20, it's going to give us 320. It's where they both match up. So we can say that there will be 30 packs of 8 batteries and 20 packs of 4 batteries. Okay, come up with a solution to that. Now again, you may use DESMOS. You will be allowed to use DESMOS on your weekly progress check as well as your exam for these kinds of things. So it's important that we understand how we can create these equations and also type them into DESMOS. Now again, if you're following my class, your assignment is LI.07, numbers 5 to 10.